Okay, this is Mr. Dittmer, American Indian Public Charter High School, Algebra 2, fourth video on section 14.6. No new, just continuing from the third video. Now we're solving an equation using the sign, or the trig sum and difference formulas. So here's the equation: sine, parentheses, x plus pi over 4, close parentheses, plus 1 equals sine, parentheses, pi over 4 minus x. For 0 is less than or equal to x is less than or equal to 2 pi. So we're talking about, there may be many solutions, but we only care about the ones between 0 and 360. So to make this doable, let's see what happens if we use the formulas we learned on them. So this is the sum formula for this one. And we go sine x cos pi over 4 plus cos x sine pi over 4. Then bring down the plus 1 equals, and then use the difference formula on this side, and I put that in green, sine pi over 4 cos x minus cos pi over 4 sine x. Tricky because you got to make sure you realize that on this side, u is pi over 4 and v is x. And on this side, u is x and v is pi over 4. So you just apply the formula to each side separately, and hopefully you get it in the right order. I think I did, and then so the next question is going to be to manipulate this equation around like just a bunch of algebra stuff that it is. So what we want to see is, are there like terms? So sine x cos pi over 4, well, that's not what this is, but that is what this is. They're in a different order, but it's just like AB and BA, same thing. Sine x cos pi over 4. On this side it's negative, but on this side it's positive. And then cos x sine pi over 4, cos x sine pi over 4, these are the same, and we can just subtract them from both sides. That's what we're going to do. We're going to subtract them from both sides. And now and this, since it's a like term with this, we can subtract it from both sides, and that'll cancel it on this side. We'll just get 1 equals, and it's what this is like. I mean, if you just for a minute think of this as, x plus 1 equals negative x. And you'd subtract x from both sides, and then you'd get 1 equals negative 2x, right? Negative x minus x is negative 2x. Therefore, but it's not x, it's sine x cos pi over 4, so it's negative that, negative 2 cosine pi over 4 sine x. And then we can divide by negative 2, we get negative 1/2 equals, and then we know what cos pi over 4 is. It's because pi over 4 is 45, and sine and cosine of 45 are root 2 over 2, and then we're going to end up dividing by root 2 over 2 on both sides, and that allows us to get sine x by itself. Dividing by a fraction means multiplying by its reciprocal, so really this is negative 2 over 2 root 2, and these cancel, so it's negative 1 over root 2, and then you've got to multiply by root 2 on top and bottom, and you'll end up with negative root 2 over 2 equals sine x. So then we ask, where does sine x equal negative root 2 over 2? And since that value is the 45-degree one, we're just looking for anywhere where sine is negative and the reference angle is 45. So that's going to be here and here. So what angles are those? Well, that's 225 and 315. Or in terms of radians, it is, if we're dividing that circle into fourths, we've got 4 pi over 4 over here is 180. And so then that would be, so my answers would be 5 pi over 4 and 7 pi over 4. And sorry, this is not a good visual, let me give you a better one. So that's the visual I showed you, but if we just actually browse that over here, we can see there it is, 225 and 315, and there it is, 5 pi over 4, 7 pi over 4. And you just think of the 45s are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So those are the only two places where the sign will be negative root 2 over 2. Sign is negative down here. And so that should be our answer for the solution of that equation. X is 5 pi over 4, x is 7 pi over 4. Now, if you want a challenge problem to, what am I talking about? You don't want a challenge problem. Well, but if you do, on page 871, example 6, they try to put this in a real world context. The heights in inches of pistons 1 and 2 in an automobile engine can be modeled by a sine function. And the question is, when are these pistons at the same height? So it's like a system of equations with two sine functions. You're solving an equation like this, like this, like this, and like this, using so you're imagining, using the sum and difference rules we just used. So if you have two sine functions, you set h1 equal to h2, and solve for t. How often does t how many solutions are there for t where basically how often are these pistons at the same height? So just like in our previous problem, x was true at 5 pi over 4 and 7 pi over 4. These two things should be equal to each other at various values of t. So at those values, when we solve for t, we should get an answer for this. So let's put that off for tomorrow. Have a nice day.